Hello everyone. Let us discuss the grouping of cells. At the end of this video session, you will be able to connect cells in series, parallel, and series-parallel combinations. What is meant by cells? In electricity, cells are a voltage source or EMF with a small value when many cells are grouped to form a desired voltage source. Simply, cells are small batteries or portable voltage sources that are used in clocks, remotes, toys, etc. These batteries have a voltage of 1.5 and a maximum of up to 4.2 volts. How do cells generate electric energy? Cells provide electric energy through chemical reactions. The cell basically consists of two electrodes known as the positive and negative. The electrolyte solution is filled with these electrodes. The positive terminal of the cell has a metal cap, while the negative terminal has a flat metal disc, as can be seen when you examine the cell. The current begins to flow when the positive and negative terminals are connected to the electrical appliance. The chemicals get used up over time and the cell cannot produce electric energy anymore. How many cells are used in batteries? One of the main applications of the cells is batteries. Other applications make use of lead-acid batteries. These batteries can be recharged after the energy is used. Every battery is made up of a group of cells. Every cell has its own EMF or voltage source, and it is connected in a way to bring the desired voltage of the battery. What are cells made up of? Cells are made up of two electrodes, nothing but a solid conductor. One is for positive terminals, also called anode, and the other one is for negative terminals, namely as cathode. The charges are stored in these electrodes. The thickness of the electrodes is determined by the current rating. The thickness of the electrode can store more charges and the ampere rating will also increase accordingly. These two electrodes are immersed in a liquid called electrolyte. Electrolytes are liquids which allow the current to flow. In primary cells, the electrolytes are in the form of a paste made up of potassium, sodium, magnesium, etc. that differs according to the types of battery. In secondary cells or lead-acid batteries, sulfuric acids are used as electrolytes. The symbol of the cell is drawn with two parallel lines. One is big and the other is small, indicating the positive and negative terminals respectively. Since current is an electron flow, electrons are negatively charged particles and it starts to flow from negative electrodes to the load, which is known as current flow. This was actually happening, but this method is not used for theoretical calculation due to some difficulties. So it is assumed that the current starts to flow from positive to negative terminals, which is the opposite to the electron flow. This current flow is called conventional current flow. Grouping of cells. Grouping of cells are nothing but connecting the cells in series and parallel to get the desired voltage. Series connection of cells. The cells are said to be connected in series if the positive terminal of the first cell is connected to the negative terminal of the second cell and the negative terminal of the second cell is connected to the positive terminal of the third cell. The same current flows through each cell but the voltages are additive. Always remember that in a series circuit, the current remains the same and voltage values are additive throughout the circuit. To obtain 12 volts, you can connect 6 numbers of 2 volt cells in series, or you can connect 8 numbers of 1.5 volts in series, or you can connect 10 numbers of 1.2 volts in series. In 12 volt lead acid batteries, usually a 6 number of 2 volt cells are connected in series. For 24 volt batteries, 8 numbers of 3 volt cells are connected in series, or you can use 12 numbers of cells with 2 volts all in series. If any of the cells in the series connection is reversed or the polarity is reversed, the current in that particular cell level will start to flow in the opposite direction, reducing the total voltage. Assume that 3 cells V1, V2 and V3 are connected in series and each has a voltage of 2 volts, so the output voltage will be 6 volts. If the cell V3 terminals are reversed, current flow reverses, hence 2 volts corresponding to V3 is reduced from the total voltage and the output voltage becomes 4. Let us discuss the behavior of currents. Before entering the current, we need to know about internal resistance. What is internal resistance? We already know that resistance is the property of the conductor that opposes the current flow and causes the voltage drop. Internal resistance is also a resistance that occurs in the voltage source of the cell. As we discussed earlier, cells are made up of electrodes. These electrodes will have resistance. This resistance is also taken into account because the current flows through the load via electrodes in the cell. Simply, it is the resistance to the flow of current when the circuit gets because of the electrodes and electrolyte present in the battery or cell. That is why a cell is always represented as a voltage source with series resistance. The internal resistance is denoted by the letter R and the unit is ohm. Internal resistance is typically between 0.1 and 0.9 ohms. Let us calculate the current value. Assume 2 cells are connected in series. Each cell has a 2 volt with an internal resistance of 0.1 ohm and is connected across the lamp. Let the load resistance be 2 ohms. According to Ohm's law, we used to find the value of current. I is equal to V by R. Simply, I is equal to total voltage by total resistance. Let's find out the voltage V. Since it is a series circuit, the voltage of each cell is additive to that present in the circuit. So, the voltage becomes 4 volts. Ensuring the voltage by connecting a voltmeter across or parallel to both cells, now we go for resistance R. Actually, the circuit consists of 2 resistances, internal resistance R and the external resistance or load resistance R. We know that in a series circuit, the resistant values are additive. So, the total resistance becomes R plus R. We get it as 2.2 ohms. Substitute the values in the formula. I is equal to 4 by 2.2. I is equal to 1.818 amps. Connect an ammeter series with the circuit and ensure the ammeter reading shows 1.8 amperes of current. Let us discuss another example. Assume 4 cells V1, V2, V3 and V4, each of which is 1.5 volts and has an internal resistance of 0.2 ohm are connected in series. To configure cells with a series connection, each cell must have the same voltage and internal resistance. 2 lamps L1 and L2 are connected in series to each other and also in series with the circuit. The load resistance across L1 and L2 is R1 and R2 respectively, and the values are 2 ohms each. To calculate the current according to Ohm's law, I is equal to V by R. Since the circuit is series, all voltage values are additive and all resistant values are additive. The voltage becomes 6 when we add V1, V2, V3 and V4, and the total internal resistance becomes 0.8 ohm by adding R1, R2, R3 and R4. Connect a voltmeter which is enough to read 6 volts parallel to all the cells. The circuit resistance becomes 4 ohms. Since the 2 lamps L1 and L2 are connected in series, 6 volts is divided equally between each lamp as 3 volts. Hence, the total resistance in the circuit is 4.8 ohms. Substituting the values in the formula, I is equal to V by R equal to 6 upon 4.8, we obtain 1.25 amps. Ensure this using an ammeter by connecting it series with the circuit. Thank you for your time. Have a good day.